So today I want to show you how to actually use the slope to graph a line. These are going to look a little different. They might look a little familiar too. And don't let the vocabulary here worry you too much. An equation of a line can be written a couple of different ways. It can be written as a function, which we've actually already done. We graphed a whole bunch of linear functions last unit, something that looked like this. Okay, you know that when you graph those, they were a straight line. Well, these are still functions, but they're not going to be written quite like functions. You'll see some similarities though. So what I want to do is take a second and just look at these two functions. I want to take these x values and plug them in and evaluate the functions. So when I do that, and you can do these in your head, but grab a calculator if you need to, I'm going to take each x value and I'm going to plug it in into the actual equation up here. So 2 times -2 minus 3, that's -7. So I get the ordered pair -2, -7. Same thing when I plug in 0. 2 times 0 minus 3, that's -3. Then I'm going to plug in 3. 2 times 3, that's 6. Minus 3 is 3. Now, this is kind of like the tables that we had before. We've got an x column and we've got an f of x column, or in this case, they're y values. So that's going to make up ordered pairs that we can graph, just like we did with the functions, only we're not calling them f of x's. So I've got these 3 different points. Now, I only ask you to plug in 3 x's. You could plug in 1,000 different x's, and every single y value you get out would pair up with an x and create a point that is on that specific line. Y equals 2x minus 3 is a line. Every single x value has a partner y that creates a point that's on the line. I'm only asking you to graph 3 or 4 of them, but you could graph 100 if you had a graph big enough, and every single one of them would line up. All right, moving along. This one looks a little trickier because of the fraction, but don't worry about it too much. Again, if you need help evaluating these on your calculator, if you're having trouble with the fractions, let me know. We can get this squared away pretty easily. So -2/3 times -6, that is +4, plus 4 is 8. Again, these are x values we're plugging in, so they're going here, and I'm getting y values out, or this one. It's a little bit backwards because normally when you graph, x comes first, then the y, but in the equation, the y comes first, but then the x is second. So then when I plug in 0, -2/3 times 0 is, sorry, the flash, -2/3 times 0 is 0 plus 4. And then -2/3 times 9, that's -6 plus 4 is -2. Again, if I graphed all of those, they would line up nice and neat. Like the homework from the last couple of days, you're not going to have 2 that line up and then a third one that's way off kilter from the rest of them. Now, there's something kind of interesting that I want to highlight here, and it's basically the basis for everything that we're going to be doing when we graph an equation of a line. These 2 that I didn't erase, there's a reason I didn't erase those. I want you to see if you can tell what's going on here. Right? Take a look at what we plugged in and what came out compared to the equation that I gave you. Pause for dramatic effect. What I want you guys to realize is that the number that came out when we plugged in 0 is the end of the function here. It's the end of the equation of the line. That specific point, when you plug in 0, what comes out is called the y-intercept. Basically, that's a fancy way of saying this is where the line is going to cross the y-axis. Where the x value is 0, you don't move left and right at all, it is at -3 or +4 or whatever that tail end number is that's in your equation. Basically, this is going to be your starting point for your graph without me actually giving you a starting point for your graph. So if you've done the last couple of assignments where I tell you specifically what point to start at, and then you've got your slope to move, I'm not going to give you that starting point. It's kind of embedded in the function. So I know that there's these functions all look the same. It's not really a formula, but it's kind of a pattern from one to the next to the next, so you know where all of your pieces are going to be every single time. So every single equation that you're going to be dealing with when you're graphing these are in slope-intercept form. That means they are set up in this format every single time. You're going to start out with a y, then you're going to have an equal sign, and then you're going to have m, which is our slope, It's going to be the slope of the line. You don't have to calculate it. It's going to be there. Then you're going to have an x. The y and the x are actual variables in the function. They're going to be there every single time. What's going to change is what's there for the m and what's there for the b. Those two numbers will trade out from time to time to time. The m is your slope, and the b is that y-intercept that I was talking about. So these two equations here are both in that slope-intercept form. I know, maybe it's just my years of experience, but I want you guys to be able to just look at these and say, oh, I know the y-intercept of that one is 5. I know that that line is going to cross the axis at 5, the y-axis. Because my x is 0, I'm not going to be moving left and right at all on this one. I know that my point is going to be right there. Okay, your y-axis is where you're going to start your graph. From there, the number in front of the x is your slope. That's going to be your directions to more points. Now remember, your slope needs to have a numerator and a denominator, so I'm going to put a 1 underneath that. From my 5, my y-intercept, I'm going to count down 2 units and 1 to the right. Down 2 more units and 1 to the right. I'm asking you guys to graph 3 points at least. You can graph more, that's fine, but it's not going to change anything. So I'm going to draw my line here. There we go. I don't care what color you use, it doesn't matter. All right, same thing on the next one. My line, my y-intercept is at positive 8. So I know that my graph is going to, my graph of my line is going to cross right there at 8. So my slope is -3. Remember, put your negative in the numerator. -3 over 2. So I'm going to move down 3 units, 2 to the right. There's my next point. Down 3 units, 2 to the right. There's my next point. So again, when you graph, try and make your lines as long as possible. Do your best to hit all of your points. Okay? These don't change. They don't get any harder. The only thing that you're going to have to look out for are the negatives. If you've got a negative, make sure you put that negative in the numerator. So starting at -10, up 1 over 2, up 1 over 2. Oops, I moved 3. Got to fix that. There we go. Starting at +1, up 5 over 4, up 5 over 4. Yep, pay attention on these. It's really easy to get off one. Okay. Take your time, double check your points, graph at least 3 of them.